Here in the I button and in description box below, you will get complete playlist of Fourier series. Welcome to video number 8, and in this video we are going to solve second problem on the topic that is functions having points of discontinuity. Okay, this is video number 8 of Fourier series, and before I start this video I would request you to subscribe to my channel, and if you learn something from my videos then please hit the like button and do share the playlist of this Fourier series with your friends. Okay, in this way only you can support me. Let us try to solve this problem. The question says if f of x equals to, yes, here we have two functions that is 0 when the limit of x varies from minus pi to 0, and function becomes sine x when the limit is from 0 to pi. Okay, hence prove that f of x equals to 1 upon pi plus sine x upon 2 minus 2 upon pi summation n equals to 2 to infinity. Yes, this is n equals to 2 to infinity cos n x upon n square minus 1, and hence show that 1 upon 1 into 3 minus 1 upon 3 into 5 plus 1 upon 5 into 7 minus dot 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 equals to 1 upon 4 pi minus 2. Okay, this is my problem. Okay, so here again you can see this minus pi is the lowest limit and this pi is the highest limit. So this is the value of b and this is the value of a. So b minus a, that is pi minus of minus pi, that is 2 pi. Okay, so since b minus a equals to 2 pi, hence we can say the Fourier series for the given function f of x is given by f of x equals to a naught upon 2 plus summation n equals to 1 to infinity an cos nx plus summation n equals to 1 to infinity bn into sin nx. Okay, this is, let's suppose, my equation number 1. What we need to do is simply find the value of a naught, an and bn. Put the values of a naught, an, bn here. This will be the Fourier series expansion of function f of x. Now let us find what is a naught. Okay, yes, we know that the formula for a naught by the help of Euler's formula, that is 1 upon pi integration a to b f of x dx. Okay, yes, so it is 1 upon pi. Yes, we have two limits. Okay, yes, here you can see when the limit is from minus pi to 0 the function f of x is 0. When the limit is from 0 to pi the function f of x is sine x. So here we are going to use that is when the limit is from minus pi to 0 the function f of x is 0. Okay, so integration minus pi to 0 dx plus, yes, when the limit is from 0 to pi. Okay, yes, in that case the function becomes sine x. So integration 0 to pi sine x dx. Now this part will become 0 because of this 0. Okay, so we are going to solve this part only. So here we have 1 upon pi. Yes, integration of sine x will become minus cos x. Okay, so cos x limit is from 0 to pi. Okay, now take this negative here, that is minus 1 upon pi. Put upper limit, that is cos pi minus lower limit, that is cos 0. Okay, we know that cos pi is minus 1 and cos 0 is 1. So minus 1 minus 1, that is minus 2. So minus 2 into minus 1 will become 2 into, sorry, this is 2 upon this pi. Okay, so what we have, the value of a naught becomes 2 upon pi. After this we will find what is an. Okay, so let us find what is an by the help of Euler's formula. An equals to 1 upon pi integration a to b f of x cos nx dx. Again, yes, 1 upon pi integration minus pi to 0. Okay, the limit is minus pi to 0. In that case function is 0. So 0 into cos nx dx plus integration 0 to pi. Yes, when the limit is from 0 to pi, in that case function f of x is sin x. This is given in the problem only. Okay, so f of x is sin x when the limit is from 0 to pi. So cos nx into dx. Now since 0 into something is 0, so yes, this limit is going to be 0. So we will be solving only this part. Okay, yes, here you can see, here we have sin x and here we have cos nx. N is present in this part, so first we'll write cos nx. Okay, and here we will be using this formula, that is 2 cos a sin b. Okay, here we will be using this formula, that is 2 cos a sin b. For this we need to have here 2. Okay, so we will multiply and divide 2. Okay, so this is going to 1 upon 2 pi integration 0 to pi. This is 2 into cos nx into sin x dx. Now simply use this formula. Here a is what? Nx. B is what? X. So yes, Sine a plus b, that is sine nx plus x. Taking x common, we have sine n plus 1 x. Minus sine a minus b. What is a? A is nx. What is b? B is x. So it is going to be nx minus x. Taking x common, we will have sine of n minus 1 into x. Okay. Don't forget to write this dx here. Okay. Now we will simply integrate this part. Okay. So this is 1 upon 2 pi as it is. Yes, integration of sine is minus cos. Okay, integration of sine is minus cos. So minus cos n plus 1 x upon coefficient of x, that is n plus 1. Similarly here also sine, integration of sine is minus cos. Because of this negative, this will become plus. Okay, sine of integration of sine is minus cos, minus minus will become plus. So cos of n minus 1 into x upon coefficient of x, that is n minus 1. Okay, limit is from 0 to pi, 0 to pi. Now here 1 upon 2 pi. Okay, yes, we are writing this. Okay, this term first and this term second, but applying at the same time limits also. So if you put limit here, upper limit minus lower limit, so this is going to be cos of n minus 1 pi upon n minus 1. Similarly here, if you put the lower limit, this is going to be cos of n minus 1, 0, that is cos 0 upon n minus 1. Again coming to this part, if you put the upper limit, minus of cos n plus 1 into pi upon n plus 1. Upper limit negative, so lower limit would be positive. Okay, cos 0 upon n plus 1. Fine. Yes. Here 1 upon 2 pi is as it is. Since we know that cos of n pi is what? Minus 1 power n. Okay, cos of n pi equals to minus 1 power n. So cos of n minus 1 pi will be minus 1 power n minus 1. Okay, yes. So taking LCM common. Okay, so taking LCM for these two terms, that is n minus 1. Yes, this is going to be minus 1 power n minus 1. This is going to be 1. Cos 0 is how much? 1. So this is minus 1 power n minus 1 minus 1 upon this n minus 1. Again we will take this. Okay, yes, cos 0 is how much? 1, and this is how much? Minus 1 power n plus 1. Okay, upon n plus 1. Okay, now here you can see one thing, that is in the denominator we have n minus 1. Okay, in the denominator we have n minus 1. So if you put, yes, in the Fourier series you have n equals to 1 to infinity. Okay, if you put n equals to 1 here, this term is going to be infinite. So this is the value of an when n is not equals to 1. It means the value of n starts from 2 to infinity. Okay, yes, here this is the value of an. Okay, when the value of n ranges from 2 to infinity, it means we need to find a1 separately. Okay, yes. Now here we have two conditions, that is, yes, when n is odd and when n is even. Okay, why we are doing so? Yes, we are doing so because we need to prove something. Okay, yes, in the question itself it is given that prove that f of x equals to this. Okay, yes, so we are finding the odd and even values. Okay, yes, so here when n is odd, it means n equals 3, 5, 7, 9 and so on. Okay, let's suppose here we have n equals to 3. So 3 minus 1. Okay, 3 minus 1, that is 2. Minus 1 power even will become 1. 1 minus 1 will become 0. So this term will become 0. In the same way, if you put n equals to 3 here, 3 plus 1, that is 4. Okay, minus 4 power even. 4 is even number. Minus 1 power even will become 1. 1 minus 1 will become 0. So if n is odd, if we put n equals to odd number like 3, 5, 7, 9, this both terms will become 0. In that case we can say that is an equals to 0. Okay, but when n is even, okay, in that case this is going to be minus 1, this is going to be 1. Okay, yes, so sorry, this is going to be minus 1, this is going to be again minus 1, so this is going to minus 2 and this is going to be 2. Okay, yes, in that case this is 1 upon 2 pi, this is going to be minus 2 upon n minus 1, this is going to be 2 upon n plus 1. Okay, now simply solve this taking LCM, that is this is going to be n square minus 1. Here we have 1 upon 2 pi as it is. Simply multiply minus 2 with n plus 1 and multiply 2 with n minus 1 with this addition. Okay, yes, here you can see minus 2n plus 2n will get cancelled. You will get minus 4 upon 2 pi into n square minus 1. Okay, if you this is 2. Okay, so we will get minus 2 upon n square minus 1 into pi. Okay, yes, here we will get n square minus 1 into pi. This is the value of a n. Okay, remember that this is the value of an when n is not equals to 1. Remember this thing, that is n is not equals to n is not equals to 1, because if you put n equals to 1, this term is going to be infinite. Okay, so this is the value of an, so we need to find a1 separately. Okay, if you put n equals to 1, in that case we have this term is 0. Okay, so this is going to be 1 upon pi integration minus pi to 0 into cos n pi, sorry, n x dx. N equals to 1, so this is going to 0 into cos x dx plus integration 0 to pi sin x into cos x, because n equals to 1, sin x into cos x dx. Okay, yes, we will be using a1. Okay, we will be finding a1 when n equals to 1, that is integration minus pi to 0. This will be there. Okay, 1 upon pi into integration minus pi to 0 into cos x dx plus integration 0 to pi sin x cos x dx. Okay, we will be solving this part. Yes, here we have, that is a1, 1 upon pi integration minus pi to 0 into cos x dx plus integration 0 to pi, we have sin x into cos x dx. Now this term will become 0, because of this 0 into something will become 0, so we will be solving this part only. Okay, now here we will multiply 2, okay, and divide 2. Okay, so that this will become 2 cos 2 sin a 2 into sin x cos x. Okay, 2 into sin x cos x is sin 2x. Okay, yes, so this is going to 1 upon 2 pi integration 0 to pi, this is going to be, yes, sin 2x. Remember one thing, that is we have multiplied 2 and divide 2, so this is going to be 1 upon 2 pi integration 0 to 2 pi, sorry, 0 to pi sin 2x dx. Now we will integrate this. Okay, yes, we will integrate this. This will become 1 upon 2 pi, as it is integration of sin is minus cos. Okay, so minus cos 2x upon 2, limit is from 0 to pi. Now if you take this 2 here and negative here, this is going to be minus 1 upon 4 pi. Okay, minus 1 upon 4 pi. Simply put limit, that is cos 2 pi minus cos 0. Okay, yes, minus cos 0. Cos 2 pi is 1. Cos 0 is 1. So cos 2 pi 1. Cos 0 1. 1 minus 1, that is 0. So 0 into anything will become 0. So here we have a1. Okay, a1 value of a1 is how much? 0. Okay, now after this we will find what is bn. Bn equals to 1 upon pi. Yes, by Euler's formula we have this formula. Okay, 1 upon pi integration minus pi to 0, f of x is 0. Okay, when the limit is from minus pi to 0, the function f of x is 0. So 0 into sin nx dx plus when the limit is 0 to pi. Okay, when the limit is from 0 to pi, in that case function is sin x. Okay, so integration 0 to pi sin x into sin nx dx. Now this term will become 0 because of this 0. Okay, now we will solve only this part. So again we will multiply 2 and divide 2, so that this will become 2 into sin nx into sin x. Okay, yes, 1 upon 2 pi integration 0 to pi 2 into sin nx. Okay, n is contained in this part, so I will write this part first. Okay, 2 into sin nx into sin x dx. Okay, here we are going to use this formula, that is 2 sin a sin b equals to cos a minus b minus cos a plus b. Okay, very important formula. 2 sin a sin b equals to cos a minus b minus cos a plus b. Okay, yes, so this is 1 upon 2 pi. Okay, this is 1 upon 2 pi as it is. Again integration 0 to pi. Okay, now what is a? That is nx. What is b? That is x. So this is going to be cos of a minus b minus cos of a plus b, that is cos of n minus 1 into x minus cos of n plus 1 into x. Simply write dx here. Okay, don't forget to write this dx here. Okay, now 1 upon 2 pi is as it is. If you integrate cos, you will get sine. So sine of n minus 1 into x upon, yes, coefficient of n is coefficient of x is n minus 1, so simply write n minus 1 in the denominator part. Again here we have negative sign, write here negative. Integration of cos is sine, so sine n plus 1 upon n plus 1 into x upon coefficient of x, that is n plus 1. Okay, now put the limit, that is 0 to pi. Okay, now here both will become 0. Okay, if you put pi or you put 0. Okay, if you put pi in place of x, I mean to say when you put the upper limit, both term will become 0. When you put the lower limit, both term will become 0. Okay, so bn will become 0. Okay, but there is a important point, that is here we have n minus 1 in the denominator part. Okay, here we have n minus 1 in the denominator part, so we cannot put n equals to 1, because if you put n equals to 1, this whole term will become infinite. Okay, this whole term will become infinite. So we can say bn equals to 0, but the value of n ranges from 2 to infinity. Okay, that is when n is not equals to 1, bn equals to 0. It means we need to find b1 separately. Okay, let us try to find bn. Okay, now to find bn, we'll put n equals to 1 here. So this is going to be integration, sorry, this is 1 upon pi, integration minus pi to 0, 0 into sine x. Okay, because n equals to 1, so this is going to be sine x dx. Here also integration 0 to pi, here we have sine x into dx, that is sine square x dx. Okay, now here we need to use this formula, that is we know that cos 2x equals to 1 minus 2 sine square x. Okay, cos 2x equals to 1 minus 2 sine square x. So sine square x equals to 1 minus cos 2x upon 2. Okay, sine square x equals to 1 minus cos 2x upon 2. We'll be using this formula here. Okay, this term will become 0 because of this 0. So b1 equals to 1 upon pi into this. Fine? Yes. Now solve this part. 1 upon pi. Okay, 1 upon pi, integration 0 to pi. Here we can write that is 1 minus cos 2x upon 2. Okay? Yes. Don't forget to write dx here. Okay? Now, yes, we are taking this 2 here. That is 1 upon 2 pi. Okay, 1 upon 2 pi. Yes. Now, if you integrate this, okay, that is dx only. Okay, minus integration of cos 2x. Okay, with respect to x, and the limit is from 0 to pi. Okay. Now here we will get, here you are going to get x. Okay, 1 upon 2 pi is as it is. Here you will get x, limit is from 0 to pi. Here you will get sine 2x upon 2. Okay, integration of cos is sine. Okay, integration of cos is sine. Integration of dx is x. So x, limit is from 0 to pi. Here we have sine 2x upon 2. Okay, why 2 is here? Because 2 is the coefficient of x. So simply write 2 in the denominator part, and the limit is from 0 to pi. Now if you put the limits, okay, now simply put the limits. 1 upon 2 pi is as it is. If you put the upper limit, that is pi, minus lower limit, that is 0. So pi minus 0, that is pi. Okay, now coming to second term, that is minus 1 upon 2. If you take this 2 outside of this bracket, you will get minus 1 upon 2 as it is. Now simply put the limits. Okay, if you put upper limit here, this will become sine 2 pi. If you put the lower limit here, this will become sine 0. Okay, sine 2 pi minus sine 0. Upper limit minus lower limit. Both term will become 0. Okay, sine 2 pi is 0. Sine 0 is also 0. So we can say we are left with 1 upon 2 pi into pi. Okay, so 1 upon 2 pi into pi will become 1 upon 2. So we have the value of b1 also, that is 1 upon 2. So finally we can say that we are having a not equals to 2 upon pi. Okay, n equals to minus 2 upon n square minus 1 into pi when n is not equals to 1. We have found a1 separately, that is 0. Okay, a1 is 0, bn is also 0, and b1 is 1 upon 2. Okay, b1 is 1 upon 2. Okay, so finally we can say that is f of x. Okay, the function f of x equals to a naught upon 2. A naught upon 2 means 1 upon pi. Okay, yes, plus summation n equals to 1 to infinity. Let me show you once again. Yes, what is equation number 1? This is my equation number 1. Okay, yes, this is my equation number 1. That is a naught upon 2 plus summation n equals to 1 to infinity an into cos nx plus summation n equals to 1 to infinity bn into sin nx. Okay, but here you can see one thing, that is here an, okay, the value of an exists when n is not equal to 1. Okay, yes, so we have found a1 separately. Okay, yes, here we have 1 upon pi minus, here we can take common, that is minus 2 upon pi we can take here. Okay, that is minus 2 upon pi summation n equals to 2 to infinity, because at n equals to 1 a1 equals to 0. Okay, at n equals to 1 a1 equals to 0. So this an, okay, for this n starts from 2 to infinity. Okay, yes, so we are left with 1 upon n square minus 1 in the denominator part into cos nx. So this is going to be cos nx upon n square minus 1 plus no need to write a1 and bn. Okay, simply write b1 part. So b1 means half. Okay, n means here the value of n is how much? 1. So this is going to be sine. Here we had sine nx, but n equals to 1, so we have sine 1x, that is sine x, and this is the coefficient of sine x, that is b1 into sine x. And what is bn? That is 1 upon 2. 1 upon 2 into sine x. Okay, now if you can expand this, that is also good, that is 1 upon pi minus 2 upon pi is as it is. Simply put n equals to 2. Okay, this is going to be cos 2x upon 2 square minus 1. If you put n equals to 4, okay, because here we have one more thing, that is, yes, n is, if n is odd, then an becomes 0. Okay, if n is odd, then an equal to 0. So we need to take only even terms only. Okay, even parts only. So 2, 4, 6. Okay, so this is cos 2x upon 2 square minus 1 plus cos 4x upon 4 square minus 1 plus cos 6x upon 6 square minus 1 plus dot dot dot. Okay, and this part is as it is, that is half sine x. This is the, yes, Fourier series of the function f of x. Now we need to we need to prove one more thing, that is this part. Okay, after, yes, we have proved this first part. Now we need to prove second part, that is 1 upon 1 into 3 minus 1 upon 3 into 5 plus 1 upon 5 into 7 minus dot 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 equals to, okay, that is 1 upon 4 into pi minus 2. To get this value, you need to remember one thing, that is at what value of x, okay, at what value of x we are going to achieve this result. Okay, if you don't remember that value of x, then don't go for this part. Okay, now put x equals to pi by 2 in this equation. Okay, if you put x equals to pi by 2 in this equation, you will get the required result. Okay, now here we need to know, yes, here we have pi by 2, and here if you see in the problem itself, something is given. Okay, yes, x equals to pi by 2, then we will get this result. But at x equals to pi by 2, what is the function? Okay, yes, here you can see, if the limit of x ranges from 0 to pi, then the function becomes sin x. Okay, it means when x equals to pi by 2, the function is sin x. Okay, the function is sin x. So here we are going to use this. Okay, yes, so put x equals to pi by 2, so function will become sin x, that is sin pi by 2. Okay, here we have 1 upon pi minus 2 upon pi. Okay, here simply put x equals to pi by 2, so this is going to be cos pi, this is going to be cos 2 pi, this is going to be cos 3 pi, and so on. Okay, in denominator part you have 4 minus 1, that is 3, 60 minus 1, that is 15, 36 minus 1, that is 35. Okay, plus dot dot dot. Okay, now again sine of pi by 2, what is sine of pi by 2? That is 1, so half into 1 will become half. Okay, now, yes, sine pi by 2 is 1, we are taking this half to the left hand side. Okay, so this is going to be 1 minus half. Okay, that is half again. Okay, so here also we have 1 upon pi minus 2 upon pi. Cos pi is how much? Minus 1. Okay, so this is minus 1 upon 3. Cos 2 pi is plus 1, that is 1 upon 15. Cos 3 pi is again minus 1, that is minus 1 upon 35 plus dot dot dot. Okay, now on solving this we'll get half. Now again we are taking this to the LHS. Okay, left hand side, that is half, this will become negative, half minus 1 upon pi. Okay, and here, yes, here we have minus 2 upon pi into this. If you take negative common, this will become positive. Okay, if you take negative common, this will become positive, this will become negative, this will become positive, and so on. Again, negative and negative, this will become positive, so this is 2 upon pi. Here we have 1 upon 3 minus 1 upon 15 plus 1 upon 35 minus dot dot dot. Okay, yes, if you take LCM, that is, here we have 2 pi. Okay, and here we have pi minus 2. Okay, now if you compare both, pi will get cancelled. Okay, pi will get cancelled. Okay, yes, pi will get cancelled. It means, yes, we have 1 upon 3 minus 1 upon 15. 1 upon 3 can be written as 1 upon 3 1 into 3. 1 upon 15 can be written as 1 upon 3 into 5. 1 upon 35 can be written as 1 upon 5 into 7 minus dot dot dot. Okay, yes, again, yes, taking this 2 here, that is pi minus 2 upon 2 into 2, that is 4. So we can write this as 1 upon 4 times pi minus 2. Okay, and this is what we wanted to prove. Okay, thank you so much.